Welcome everyone. Have you ever wondered how electrons move smoothly in topological insulators without any resistance? The answer to this question is spin momentum locking. Yes, spin momentum locking is the reason behind this. And this is a quantum phenomenon in the quantum world. Means in case of topological insulators, this quantum phenomenon occurs. So what exactly is spin momentum locking? That is the question. So spin and momentum both are properties of electrons. Yes. In this discussion we will stick only to electrons. So you know that spin and momentum both are properties of electrons. And here spin and momentum of the electrons are locked together. What is the meaning of that? Means here spin of electrons dictates the momentum. According to the direction of the spin, momentum are fixed. Okay, that means say for example an electron is moving to the right with its spin up, that state, spin up state. Okay, that means when the same electron is moving to the left, it will adopt spin down state. Just the opposite. So this is known as spin momentum locking. This phenomenon is known as spin momentum locking. According to the direction of the motion, there will be a fixed spin. That's why locking, this term is used here, spin momentum locking. That means spin and momentum both are locked together. So the same thing occurs in case of topological insulators, and this prevents backscattering. This phenomenon, this quantum phenomenon, that means spin momentum locking, this phenomenon prevents backscattering. Backscattering means what? Electrons were flowing in one direction, but if it changes its direction, means if the electrons try to move just to go in the opposite direction, in that case that will be called as backscattering. But here in this case, in the case of topological insulators, again certain materials are also there in which this phenomenon occurs. Anyway, we are in this video focusing on only topological insulators. So in case of topological insulators, whenever the electrons will try to change their direction, in that case there will be a requirement to change the spin also, spin of the electrons. Okay, but that is not allowed in case of topological insulators. That is not allowed because that spin is not available actually in case of topological insulators. Yes, certain factors are there by which you can change this, such as if impurities are present or magnetic materials are present in the topological insulators, then this can means that rule can be broken. Which rule? Spin momentum locking. That rule I am talking about. Okay, that rule can be broken by the presence of impurities, by the presence of magnetic field. Again, certain spin orbit interactions. In case of certain spin orbit interactions, the rule can be broken, and in that case spin momentum locking, that rule won't be preserved. But if these things don't occur, means everything is fine, in that case spin momentum locking, this quantum phenomenon occurs and electrons are able to move smoothly without any resistance, and that is the desired property of topological insulators, because in that case for transmission of energy there will be minimal energy loss. So that means in electronic circuits these topological insulators could be used easily to minimize the energy loss, because resistance is almost zero. So in that case energy loss will be minimum. That is one point. Again, in case of spintronics, the electron's spin could be used for information processing. In case of spintronics, that is a field of electronics. Means in case of electronics, you know that a charge is used. Okay, charge of electrons, and in case of spintronics, spin of electrons are used. So spintronics is another field. You can say this way that advanced field of electronics is known as spintronics. In short, you can say that way also. Spintronics. Okay, here spin of electrons are used in this field of study instead of charge of electrons. Again, in case of quantum computing, means fault-tolerant quantum circuits could be made possible by using this topological insulators. That means that property. We are focusing here on a specific property known as spin momentum locking. That property would easily be used for the development of fault-tolerant quantum circuits. So how this rule is protected? This rule is protected. This rule means I am talking about spin momentum protection. Some noise is coming from outside, please ignore that noise. Okay, anyway, so I was talking about what? I was talking about how this protection is possible. How this protection is possible? This protection comes from time reversal symmetry, or TRS in short. According to time reversal symmetry, when electron states move in one direction, in that case there is an exact mirror image of the electrons moving in the opposite direction. This way the time reversal symmetry is ensured. Okay. So time reversal symmetry, that is the reason behind that spin momentum locking. Anyway, so this was all about today's topic. Okay, the topic was what? Spin momentum locking. And this way, prevention of backscattering in topological insulators is possible. Backscattering actually gives rise to what? Gives rise to resistance to current flow. So to prevent backscattering, this phenomenon is used in case of topological insulators. Okay, so this was all about today's topic, and this is the end of this video. Thank you for watching this video.